We now talk about resonance. So the angular frequency omega naught at which XL is equal to XC, this is called the resonance frequency of the LRC circuit. So this is XL, omega naught L, and this portion is XC. You put them equal to each other, you solve for omega naught, you get 1 over square root of LC. So the impedance of the circuit is equal to R at the resonance frequency. So because Z is equal to square root of R square plus XL minus XC square, so this term becomes 0 when XL is equal to XC, so you just get Z as equal to R. Now we just give the definition of power factor. So power factor is nothing but voltage, maximum voltage, times the maximum current divided by 2 times cos of phi. So this cos of phi just has the phase angle in it. So there is a phase angle which we talked about in the previous lecture. Now we can rewrite Vm by root 2 times Im by root 2. So this product is equal to this Vm times Im by 2. So Vm times Im by 2, this is equal to this, and this is nothing but we write as Vi. So this is Vrms and this is Irms. So that's why we are writing it as capital V and capital I. So this capital V is Vm by root 2, capital I is Im by root 2. So let us now discuss an example. So LRC circuit is connected to a AC source. So now we are given maximum voltage. So this 150 volts is the maximum voltage. We have V subscript M and a frequency of 60 Hertz. So this LRC circuit has three things. Obviously it has a resistance of 425 ohms and inductance of 1.25 Henry and capacitance of 3.5 microfarad. So it is a LRC circuit. So it has a inductance, a resistance and a capacitance. So angular frequency first we need to calculate. So angular frequency omega is equal to 2 pi f. So f is 60 Hertz. So you get omega as 377 per second. So inductive reactance XL is omega times L. Just plug in the values. So omega we computed as 377, you plug it in. L is given to us 1.25, you plug it in. So XL you get as 471 ohms. Similarly, capacitive reactance, you plug in omega, you plug in C. C is 3.5 microfarad. So micro means you have to multiply by 10 to the power of minus 6. So you compute capacitive reactance as 758 ohms. For impedance, you just use the formula. Resistance is given to us as 425 ohm right here. And then we just plug in XL as 471 and XC as 758. So you compute this, you get Z as 513 ohms. So maximum current is maximum voltage divided by impedance. So maximum voltage is given to us as 150 volts. So 150 divided by 513, you get 0.293 amperes. So what is a phase angle now? Phase angle formula is XL minus XC over R. So you get 471 minus 758 divided by 425. This implies that phi is minus 34 degrees. So phase angle here is negative because XC is greater than XL. So now you can see that the current is leading the voltage here. Now the maximum voltage will be across the resistor. You have VR, which will be Im times R. So Im, the maximum current, we calculated as 0.293 ampere right here. So you put in 0.293, multiply by resistance, you get 124 volts. Across the inductor, you have Im times XL. Again, you plug in the current. XL, you have 471 ohms right here. You plug it in, you get 138 volts. And VC, voltage across the capacitor, is Im times XC. That is a capacitive reactance. Again, the current is 0.293 and 758 you copy from here and you get 222 volts. So now we just do a check whether we have the correct answer or not. So 150 is the maximum volt which is given to you. So 150 should be equal to this equation of, so this equation is, this maximum voltage is equal to VR square plus VL minus VC square. So you plug the values in, you will still get 150, and 150 volts is what we started with. So if you were given RMS voltage and you have to do this problem, then you first convert the RMS voltage into maximum voltage by multiplying by √2.